Okay, so this is Module 2.2b, and we're going to continue on with creating and solving equations, today with an emphasis on creating the equations from verbal models. So if you look at our statement today, our statement is to create equations in one variable and use them to solve problems. So the idea is that the equations that we're going to be creating are going to be single variable, so there's only one unknown value that we're going to have or know, and not necessarily more than one, so we're always going to be focusing on just a single variable. So what we need to draw our attention to first before we continue on with this is remembering some of the trigger words that we had for addition, subtraction, multiplication, and division. So we're going to be looking for these words together to be able to kind of mix and match the operations that we're going to be doing. Now this is no different than what we did with 2.1 when we were looking at expressions and creating those, but what we need to do is take that one step further and look at some other instances that might be happening and then add this to an equation that we can create and then solve. So make sure that you remember some of these trigger words. Now, as far as equations are concerned, there's a couple more trigger words that we need to kind of discuss and that we need to talk about. So anytime you see the words is or you see the words equals, that's going to reference our equal sign. And so when we make this an equation, every single equation is going to have an equal sign. So if you see is, or you see equals, or is equal to, or anything of that manner, it's going to make sure that that's where our placement of our equal sign is going to be. Now, another thing that we need to be on the lookout for are these two phrases here. So times the sum of something called, let's say, this and that, and then times the difference of this and that. Now, what this is referencing is, notice that it's two different things in one. So sum references addition, difference references subtraction. Times is going to be your multiplication. And so what these are basically creating are, these are going to be creating some kind of distribution. So when we think about our distribution, if we think about it as a sum, it would look like this: A times parentheses B plus C, where you're going to be taking two things and adding them together, but saying, oh, by the way, multiply it by a number on the outside. And so that's going to set up distribution. If it's difference, that means subtraction, so that's going to look something like this. You're going to have two numbers subtracted together inside of a set of parentheses with a number multiplied on the outside. So if you ever see times the sum or times the difference, we're going to be setting up some kind of distribution problem, and we'll look at an example of that a little bit later. And the last one is, if you ever see the word total, or kind of working through things that are total, that means that you're going to be using some form of addition to add a bunch of terms together. So when we see total, we're going to do the addition of terms. So we'll look at a couple of examples of those on how we specifically use some of these trigger words to create and then solve our equations. Now, as we're looking at variables and constants, and those are two things that we're going to be using in this particular section. Now, we're going to be looking at kind of the idea of trigger words for variables. Now, obviously, variables stand for things that are unknown, things that can change. And so when we're looking at some of these problems, we need to be asking ourselves, is there something that's missing? Is there something that can change? Is there something that is unknown? So that we can actually use that to our advantage to say this is going to be our variable. So always be looking for that difference between variables and constants, because constants, remember, never change. These are going to be typical values that are given to you in some particular way. These are always the same, they never change. So when we're looking at constants, we have to be able to distinguish between kind of constants and coefficients. Now remember, coefficients go with variables. Yes, they're numbers too as well. But remember, variables change and coefficients go with those changing variables, where constants are always the same, and those are typically going to only be adding and subtracting. So when you're adding something or subtracting something, those typically are going to be your constants. Variables, and then I'll put down here so that we can have these, is that you could also have coefficients. And those are usually going to be in the form of some kind of multiplication or division. So when we're looking at coefficients, that's when we know that they'll go with a variable, is if they're being multiplied, where constants are usually going to be some form of addition or subtraction. So if we look at the first example that we have a very basic example here where it says the sum of 14 and a number is equal to 17. So the idea is that we want to create a simple sentence again. And now with something like this, the information is pretty much given to you, and it's not necessarily any simpler than what we need to make it, but we also need to identify our variables. So when we're looking at these, we need to identify the different pieces that we have, identify variables, identify constants, so that we can see clearly what it is that we're looking for. And at the same time, what we're going to want to look for is we're going to look for trigger words, so that we can make sure that we have all these things put together. So first of all, what I'm going to look for in the beginning is I'm going to be looking for the is equal to. Now what this tells me is that this is going to be where my equal sign resides, and if you notice, everything after this, so once you have your equal sign, everything after that is going to be after the equal sign. So when I see the words is equal to 17, that means equal 17. Now over here, if we look at the other side of this, so we have the complete other side of our equation. So notice what I've done as I looked for the equal sign, and then I have my left side, and then I have my right side. So I'm going to be looking for a couple of things. So sum means addition. So the addition of 14 and a number. And so the number, again, that's the missing piece, so that's going to be our variable. So if we look back at what we've kind of underlined and what we've kind of looked at, we're going to add together 14 and a number, and if we just kind of write that out, we're adding 14 plus some unknown variable of x. So the idea is that this is how we write this. Now we can organize this in any particular fashion that we want, but I'm going to rewrite it just a little bit further away from it. So 14 plus a number, or the sum of 14 and a number, is equal to 17. So that's how we kind of break those apart. We identify those trigger words, and we kind of identify what's missing, what's constant. Now if we wanted to, in a similar fashion that we've been doing this entire time, now we can solve these equations just like we normally do. Subtract 14 from both sides. 17 minus 14 gives us a positive 3 as an answer. So not only do we build these equations, but we also can take the opportunity to solve them as well. Now if we look at our next example, now we're going to use real words instead of just kind of given examples of what those trigger words are. So if we read through this problem, we see that Bella has a cell phone that costs $18 per month plus 15 cents for every minute that she uses the phone. Last month her bill was $29.25. How many minutes did she use her phone last month? So if we kind of remember back to that first page, the idea is our first step is going to be always looking for some kind of simple sentence that we can use. Now in this particular case, it's just Bella using a phone, and that's our 3 or 5 word summary of the situation here. But what we need to look at is we need to look at some of the trigger words that we have in this particular case. So here we have, first of all, we have plus. So there's going to be some kind of addition here. Now we say for every minute. It's going to be a unique situation, because remember, the second thing that we want to do is we want to identify our variables. Now this is going to help us as far as understanding what's going to be constant, what's going to be changing, and so in this case we want to know how many minutes. So that means that our minutes that we're going to be using this phone is going to be our variable, which we're just going to call x for the ease of use here. Now when we put these things together, we can kind of put a simple sentence to this. So it's $18 plus 15 cents, so I'll put 0.15 for every minute. So I'll say per minute. And so the idea is that these things are adding together. Now notice that this $18 per month, we don't care about the months changing, we only care about the minutes changing. So don't think that months is going to be a variable. The variable that's going to happen here is the minutes that we're using. That's what's going to be changing. That's going to be the variable in this particular case. The 15 cents, remember, that is going to kind of be our multiplier, and that eventually is going to be our coefficient. So the idea of identifying constants and coefficients is going to be the big struggle here. Now it says last month her bill was $29.25. Now if you remember from English, is a form of, or was is a form of is. So that means that we have an equal sign right there, and that's going to be equaling to $29.25. So if we read this again, so it costs $18 per month plus 15 cents for every minute, and her bill was or is $29.25. If we look at what we have written here, $18 plus 15 cents for every minute is, so that's an equal sign, $29.25. Now if we kind of convert this into some variables and numbers, we'll see that we have 18 plus 0.15x equaling 29.25. So the idea is that we break down these words into manageable pieces using our trigger words to understand where these are coming from and how they're working together, where we're always going to be multiplying, in this case, that 15 cents times the minutes, because we want to know what the cost of that is going to be. And obviously the addition comes from the plus. So breaking those down, looking at your trigger words, and then we'll go over some more examples of these in just a bit. Now the last example that we're going to be looking at, not to kind of give this away, but we're going to be looking at specifically a distribution problem and how we can use information to kind of use one variable and build upon that. And so if we look at the example and we read through this, and this is kind of already simplified when we look at this. So we have Aaron and Alice are bowling. Alice's score is twice the difference of Aaron's score and 5. And the sum of their scores is 320. Find each student's bowling score. Now the way that this is going to work, first of all, we're going to write a simple sentence. And we have to kind of think about what's going on here. So what we're given is we're given that the sum of their scores is 320. That's going to be helpful to our simple sentence, because we know that in a way, if you look at it this way, Aaron plus Alice is equal to that 320. So again, is our trigger word. Sum means addition, so the sum of their scores, the two people that we're talking about, Aaron and Alice. So if we can kind of look at these two things right here, those are going to be our kind of missing pieces. Now in this particular case, we want to be able to identify our variables. Now unfortunately we have two different people here and we have two different scores, but we have a comparison, or we have kind of a situation that can create one other person's score if we know the other person's score. So it says Alice's score is twice the difference of Aaron's score and 5. So again, if you look back at our trigger words, we have twice the difference, or in a way multiplying by 2, because that's what twice is, the difference of a score and something else. And so I said it's the difference of this and that, and so that's going to set up a distribution. Now because Alice's score is based on Aaron's score, what we're going to do is we're going to use Aaron as our variable. So Aaron, if we know Aaron's score, will also be able to tell us Alice's score. So Aaron, we're just going to say, is going to be x. So x is going to be here. Since we're adding, we're going to keep this addition, but we're going to look at the next piece. So for Alice's score, it's twice the difference of Aaron's score and 5. So the way that we would write this is 2 times parentheses the difference of Aaron's score, which we know is x, and 5, which is minus 5, and then we have a set of parentheses, and that's equal to 320. So the idea is that we can use one value and one missing item to sometimes potentially find our second one. But what I'm really trying to get at here is that we're recognizing that we have a multiplication and a subtraction problem kind of put together, and that's what creates the distribution. And then we can solve these just like we've solved everything else. So we have x plus, we can distribute this x here, or this 2 here, so we get 2x minus 10 equaling 320. we identify our like terms, 1x and 2x, so we simplify that first. 3x minus 10 equals 320. We can add 10 to both sides so that we can continue to solve. And so that gives us 3x is equal to 330. And then we can go ahead and divide by 3 on both sides. And that gives us x is equal to 110. Now again, remember that 110 represents Aaron's score. So in this particular case, Aaron bowled a 110, and the way that we would figure out Alice's score is that we would use this particular piece that we created to help us find that. Now in this particular case, let's go ahead and do that. So Alice's score had an expression of 2 times x minus 5. We plug in x, which we know is Aaron's score, so 2 times 110 minus 5. That's 2 times 95, and in this case, Alice scores a 190. And so that's how we can utilize these things, utilize distribution in creating and solving equations. Okay, and so that's it for this video on creating and solving equations when we're given verbal models.